So we've looked at the encryption, how to make it secure, 802.1x, key exchange, those sorts of things. Now we're going to manage the wireless local area network connections. And that's really what we want to do with these things. And we had the CAP-WAP tunnel before. We have the autonomous, a couple of different ways we can do it. The autonomous, the trunk link, the autonomous, and the reason we need the trunk link is because we have configured or mapped multiple SSIDs to VLANs. Other one over here, the switched LAN, the wireless LAN controller going through the switch to the lightweight access point. Still, we're going to have trunk ports because we can have multiple SSIDs, again, configured to the individual devices themselves. The CAP-WAP tunnel, the management information is going to go through it encrypted. We're going to also have a data tunnel that is not going to be encrypted. To get on to the wireless LAN controller, the initial configuration, management address is assigned. It facilitates the web access, the GUI or the SSH for the command line interface. And I think what we want to do is use a username and password. It's going to be a local username and password. And then after that, we can have console port access, RJ45 connector, and then got to be in the correct modes in order for these things to work. Having tried to configure a wireless device through the console port, I don't recommend it. It at least for me, it got really confusing when that happened. What I'm trying to find here, I just want to go through this, accessing the wireless LAN controller, the initial setup for it. Let's see what we can do. I think this one's configured and I don't want it, so we can make it go away and go down here to the devices. The ones here, it said hubs here. I guess I was on this one over here, but these are the wireless devices. And what we're going to use is that one, the WLC, the wireless LAN controller. And I'm just going to drag it, or maybe not drag it. I think what happens, packet tracer gets mad, doesn't it? I'm not sure that it's not my pen. Let me close the pen and see if that anything, and it didn't. So let me get out of here and do this all over again. Just open a different one that I think is unconfigured. Go down here and do this one is not configured. And the reason I can tell that it's not configured, because I know what I'm doing, is when I look at it, its address. And when you get a Cisco device, it's going to tell you how to connect to it. Read the documentation. And then what this one says, this one's got an address, bring it up, 192.168.1.1. It's got a 48-bit mask. What we need to do is to put this guy, and it says he's 192.168.1.1/24. Well, that's not going to work. So let's go in here and on the desktop, let's configure 1.2. And that was 28-bit, 24, 25, 26, 27, 28, 192, 224, 240, 248. Is that right? 16 plus 248. So 255, 255, 255.248. And we'll use the default gateway 1.1 because we will in a minute when we get there. Let's see if we can ping that 1.1 address. And these are the ways that they're going to come. Ping 192.168.1.1. And with any luck, okay, so we are connected to it. The initial configuration, and this is one of the things that you will be doing in that lab, and hopefully you'll do those labs, because I think that would help bring home what wireless LAN controllers are all about. We'll do HTTP 192.168.1.1. It is a non-secure connection, and it's going to take a couple minutes for it to, a few seconds at least. It seems like an eternity. And a lot of times I say, is this going to work? And maybe it's not going to work, but is it going to work? Is it going to work? Oh, it's going to work. We're now going to go in and create our local database with username and password. So I'm going to create a user called admin, and I'll use capital password 1, capital PASSWRD1, PASSWRD1. And then we're going to start the configuration. We just made a username and a password to get onto this thing later on when it becomes secure. Enter a name for your new system. Let's call it CCNA June. The United States, the calendar, the date and time, and that looks like it's in pretty good shape. The time zone, put your own time zone in here. The management IP address. When I'm actually doing the configurations, I don't want to use the 1.1. I'm going to use 192.168.1.3 because my workstation's already 1.2. The reason I don't want to use the 1.1 is I'm going to eventually use it as a default gateway. And let's do 255.255.255.0 and do 192.168.1.1 as the default gateway. The management VLAN ID 0, we can leave that there, and that should now enter 0 for the untagged VLAN. That will then put us on the untagged VLAN, the native VLAN. We can specify one if we want to. I just soon leave it right here. That way I don't have to go make a new management VLAN. I can change the native VLAN, and it's still going to follow it. The management VLAN will follow that VLAN because it's the untagged VLAN. The untagged VLAN, the native we talked about earlier. Enter the name for your network. Well, that sound doesn't really matter. Let's just say, let's call it demo. Now this didn't now. I'm going to name this one management. The management network. WPA2 personal, and I'm going to use capital P password 1 again because I can probably remember that. That's not something that we would obviously, and the VLAN here is going to be the management VLAN. DHCP server is optional. We don't have to configure it, and you won't have to configure it in the one you use. For one thing, we haven't done DHCP yet. For the other, on the lab that I've got, the DHCP is already configured. Virtual IP address, we just leave the default here. And then it says, hey, confirm, username, admin, the system name, on down the line. The things that time server, I didn't configure a time server, but the things that we have configured, and now we can apply it. The system will reboot, and once that happens, it's going to reboot and take some time. And actually, I've never had this work exactly right. 3, we need to wait for spanning tree here to then see if we can get there. I need to change the IP address of this guy, 1.2 back to 255.255.255.0 because that's the network that this one is now on. Let's see if we can ping. Let's see if it's back up. Ping 192.168.1.3, I think. Yep. So it says it is there. Now, in order to access the wireless LAN controller using the GUI, HTTPS 192.168.3, should be HTTPS, maybe it's not done yet, 3, unhappy with me, 2/24. Theoretically, I should be able to connect to it. It has to be a secure connection, HTTPS 192.168.1.3. Well, that's the way we do the configuration, and it is break time. Let me see if I can figure out what's going on with this thing during the break, why I can't get there. Questions or comments? Different file, same process. When we get there, this is, and I've already gone to connect here. We're going to get this one where we will now log in with the username that we configured. After that happens, then we can go through the configuration. We'll look at these configurations in a few minutes, and then got some labs for you to do using Packet Tracer. The wireless LAN controller ports. We have the service port assigned to the management VLAN, access mode only. The distribution port, the CAPWAP tunnel, connected, used for all of the normal AP and management traffic, connects in an 802.1q trunk mode. So when we talk about these things, all of these ports, this one has to be a trunk. This one goes the router on a stick. It needs to be a trunk connecting to the lightweight access points. These guys need to be trunks, and along the line here, let's see, they already got IP addresses, so they already have done their authentication thing after we got this configured using the pre-installed certificates to do authentication for the system. The console port, still a console port used for out-of-band management. Out-of-band means that we're using some other type of connectivity in order to do that. System recovery, initial boot functions, asynchronous connection to the terminal emulator to do these things. And then the redundancy port is used to connect to the peer controller. The simulator doesn't have a console port, but we do have console ports on these things. And again, just an autonomous access point, because when you get into it, if you get into the console port, you've got regular IP addresses, you've got radio IP addresses, you've got all sorts of configurations to do. The GUI, the web interface, is going to be, at least for me, the thing that you want to do in order to do the configuration with it. The internal wireless LAN controller logical interfaces maps the wired VLANs to the SSIDs, and we have to include the IP address, subnet mask, default gateway, DHCP server. Depending on how we've done it, we need the IP address for the interfaces, the subnet mask and default gateway. DHCP server we may or may not need to configure the location. In the one that I've been using here, we don't really have to do that, because I've got a router on a stick configured, and then it's going to go up and down the trunk port. The management interface, normal management traffic is going to be on this one. It's used to terminate the CAPWAP tunnels between the controller and the access points. Redundancy management, standby wireless LAN controller management, and then the virtual IP address facing the wireless clients. These are terms, and we'll see these, the virtual address facing the wireless clients, in order to be able to make the wirelesses configured. We'll see these things as we go through the configuration of the one. We're going to finish the configuration of the one that I actually could connect. When the controller is relaying the client DHCP requests performed by the client web authentication for these things. And then the service port used for out of band, kind of like the aux port on the routers when we do that. Dynamic, used to connect a VLAN to a wireless LAN, and it makes a logical connection from a wireless to. This is, kind of the conceptually what this is going to be. The dynamic interface, WLAN 1 to the SSID, dynamic interface, WLAN 2 to the SSID, VLAN X, the management VLAN, and then VLAN Y, the service port. The management VLAN we left alone. It was VLAN X was the native VLAN. A couple of protocols that we're going to look at, and you're going to have a couple of labs for these also, but Telnet protocol enables TCP/IP emulation. It allows remote access, remote configuration, remote configuration of these things. And I guess we could, if I could do the right things here, do the right thing, we can theoretically, quickly, let's use a switch so that we get into the why do we need an IP address on a switch? We need an IP address on a switch so that we can do remote access. Yeah, and I realize this isn't very remote, but we will telnet to it. We could put another one down here with an IP address on it and get to that device, but hopefully this will make, this is where we use that VLAN 1, interface VLAN, and then let's do an IP address 192.168.2.2.255.255.255. .0, and then we have to do the no shutdown command to bring the interface up. The other thing that we have to do, if I go in here and do the show run, if you look at the line VTY04, it just says login, which says that we can log in. Let's look at that. Let's go to this guy and give him a address of 192.168.2.3. We don't really need a default gateway because we're not going any place. And this one was 2.2, is that right? 2.2, yeah. Ping it, always check. I say that and then I don't do it. And it looks like it's not working, huh? There we go, it woke up. So if we now telnet remote access, telnet to 192.168.2.2, shouldn't work. It says the connection is refused by the foreign host. The reason the connection is refused by the foreign host is that it says we can log in, but we don't have a password set. So now let's go into config team to interface VTY04 interface, not interface, but line, and let's do password. They're the always secure password. So now then, when I try to do the same thing, if I've done it right, it'll ask me for a password. And you notice when you type in passwords on Cisco, you don't get any characters. And that's so that somebody trying to guess it or crack it or whatever doesn't know how many characters are in it. So we are now on the system. I didn't do a privilege password, an enable secret password, or an enable password. And then it says no password set. So to do remote access, we're also going to have to go into the device using the console cable. And let's go to up one and do enable secret. Now then, when I go back to this guy that I have a password and enable password set, it asks me for the password. And I can do remote configuration. Problem with Telnet is it's not a secure protocol. The username password is passed in clear text. The protocol that we want to use for these is we have to change the transport protocol when we do that. So Telnet, a protocol that enables TCP/IP terminal emulation connections to the host. A user at one site to establish a TCP connection to a login server at another site, and it allows the keystrokes to be passed back and forth from one device to the other. And that's what we were doing, passing keystrokes back and forth. The console or the line, not the console port, but the console's when we connect to the console, obviously. The line, the VTY line that I was connected to, gets reflected into the DOS window that I had there. Can accept either an IP address or a domain name if we can resolve the domain name using DNS. Telnet server is a device that listens for commands and replies to the commands. If you want to telnet to a Windows server, the Telnet client is enabled by default. The Telnet server is not. If you want to telnet to your Windows machine, you can do that, but you have to go and enable the Telnet server in order for that to work. The problem, Telnet passes the username and passwords in clear text. It's one of those older protocols that was developed in the more trusting era, before we had all these dedicated hackers trying to steal everything. In this case, it would be a username and a password in order to try to do to compromise other systems that we would have with it. So not secure. It does allow us to do things that we want to do, because once you're the network administrator and you're sitting at home on a Saturday morning and having your second cup of coffee, and then the boss calls up and says, my password, I'm locked out, I missed my password, whatever else, I need you to unlock the server. Well, you're probably going to want to do remote access rather than driving 45 minutes to work just to reset a password. Telnet process conceptually is what we would use. We're not going to use Telnet, obviously, because of the insecurities. We'll use a tunnel, an SSH or something like that in order to do that. But why do we want to do these remote access? And within the system itself, even at a lead request or an ECPI or a Blue Ridge Behavioral Healthcare, this would be the thing that we would want to do so that I can sit in my office and remote access the devices. Somebody violated port security. I can go in and restart the port. Somebody has an issue that's going on. I have a problem, or I need to look at. I want to look at the logs instead of going to the device, taking a laptop with me and connecting using the console port. I can Telnet or SSH. SSH again is going to be the preferred method, the secure shell, because it's going to be more secure. The client that you would use, and you guys probably have used this one before, both for a console connection as well as a remote connection, is PuTTY. PuTTY here, we have a Telnet connection which automatically puts in port 23 for us. SSH, it automatically puts in port 22. If we're doing a console connection, serial port. COM1, this goes back to when there were two COM ports, COM1 and COM2. And again, if you have an older machine that still has those COM ports on it, hang on to it. Console connections for the device. So we could use PuTTY here, would use PuTTY, one of the clients that is usable in order to do these remote connections with. SSH, secure remote access. It's the one that we're going to prefer over Telnet. Designed to replace Telnet, should replace Telnet, still not the default when we do this. It encrypts the communication between the client and the server in both two versions of it, version 1, version 2, and they're not compatible with each other. Everything needs to be version 1 or version 2. Version 1 uses a CRC32 cyclical redundancy check for secure communications, and it found it to be deficient, so CRC or SSH version 2 uses Diffie-Hellman encryption algorithm. More secure implementation of these things. So that's the one that we should be using. Following steps to enable SSH, configure the host name. We have to have a host name and a DNS configured, a DNS domain name. The DNS domain name doesn't have to be real. It just has to be there because it uses these two elements as part of the creation of the key that we're going to use for the encryption. So you have to have a host name, you have to have a DNS domain name. IP domain name, doesn't really matter what it is. If it is your actual domain for your company, that's good. If it's not, that's okay, because we're probably not going to be resolving in DNS. If we're resolving in DNS, it needs to be the correct one, but you have to have these in order to create the encryption key, and then generate the SSH key to be used, the crypto key, generate RSA for it, and then we're going to go to the enable the SSH transport mode, VTY 515 or whichever ones we're going to use, and then transport input SSH. I guess that we could go back and see if make that one work. Let's see. And I probably can't config T, so we want to do host name CCNA, and then we want to do what, IP domain name, and let's just do Q dot just for the heck of it, and then the crypto. I'm not sure it'll work here. Yeah, crypto key, so it'll help me out. Crypto key generate. And then RSA, this doesn't support a lot of them, general keys. We're just going to do RSA. So we will generate the key. And then how many bits do we want to have? The 512 is the default. That's not really big. And SSH version 1 takes a weaker key than SSH version 2. So if you generated a key in version 1 and it's not of sufficient length and you upgrade or change to version 2, it may not work. We'll use 2048 here. Generated, and it says OK. Do show run. The key, usually, key shows up in here because we're going to have a key in this thing, right? Show run. It said that it generated it, right? Generating the key up here, choosing the modulus. generating 2048 bits key. Keys will be non-executable. Okay, and then it said that it was done, so we have generated the key. After that, we would go into the system, and it would be config T line VTY, and they did 515 VTY 515, and we're going to do transport input. So now do a show run here. This device should be, for these lines, should be configured to do SSH. Again, it says login. We're still going to have to put a password on this in order for it to work. SSH, different protocol, different ports. Here, the VTY04 would be Telnet. If we used SSH to go to it, we still wouldn't be able to connect. We'd have to do the all the password things that we talked about in order to do that. Configure terminal, the step-by-step in order to do that. A couple of things that can go in here. Exit up one level, IP domain name, IP SSH timeout. The timeout interval that the router waits for the SSH client to respond. And then the input version, either version 1 or version 2. Login local to use the local database, whatever we're going to use, in order to do the logins. Telnet, again, we've looked at Telnet and how to configure SSH, and there's a lab. You'll basically go through those steps to do that. And then we're configuring the wireless local area network. Enable the wireless LAN controller distribution port as a web port, HTTP for the web, HTTPS for the secure. Once we get the system set up like we had, then actually, yeah, we did. We went back to it, and it allowed us to log on, and you have to use HTTPS after it gets configured. So we want to use HTTPS. We want it to be a secure connection. Can use the GUI or the command line interface to enable the web and secure web modes. And I think on these wireless LAN controllers, it's going to be there. On the Cisco devices, on the switches and the routers, they do have web interfaces. They do have web connections. They're not as complete as we're going to see with the wireless, but they are available. You do have to enable them on those devices in order to be able to connect to the web interface. TACACS Plus, we're going to have two different types of authentication servers. TACACS Plus, which is a Cisco proprietary, authenticates the user through an interactive dialogue, just like Radius. We've seen Radius a couple of times, username and password. TACACS is going to do the same thing. TACACS, Cisco proprietary, TCP. Radius is going to use UDP. Uses port 49, TCP port 49. Can use multi-factor authentication, which I don't think Radius is going to allow us to do. Radius is going to allow us to use username and password. So multi-factor authentication, we can use smart cards. We can use other things. We can use biometrics with the authentication, and the authentication is going to be to get to our devices. Cisco proprietary. Once it finishes the authentication, it sends, it's not a real, I'm going to say it's not a real sophisticated. It doesn't have the depth, we'll say, well, maybe sophistication is a good word, that you would expect to have from Active Directory. It's going to send us an accept, a reject, an error. The user authentication has failed due to an error such as a network connection, and then the device may use an alternate method for that, or continue. Authentication continues and the user is challenged for more information. And that's probably happened to you more than once when you're logging on to websites. It happens to me because if the authentication is successful, the authorization settings are enabled on the device, the TACACS server sends the accept, reject. The authorization for this thing, TACACS and Radius, can both be used for authentication, authorization, as well as accounting. So we can now use it for authorization, and it's going to send TLVs. We're going to have we actually have to have made some other configurations for it to do that. But authorizations used to control the facilities, access to services, session duration, auto commands, protocol support, and specific commands that the user can execute. Glad the power in the internet's back. That's always a lot of fun to do these things. TACACS Plus authorization process checks the user's profile information, and then it authorizes or denies access to the service requested by the user. Couple of things that happen to us is that when we log on, and we've talked about the privilege levels, and when we do, we'll make some users here in a little bit, but we have privilege level 0 and privilege level 15. This is user, and this is we'll call it enable mode, privilege exec mode, enable mode. In here we have from 1 to 14 that we can configure ourselves. Again, beyond the scope of CCNA, just that you know that you can configure when you say, what can a user do? So we can configure user in mode 1, we can configure specific commands that it can use. And then U2 will be different commands. So when we put these usernames and passwords in the TACACS server, we can also give a privilege level. We can also do this privilege level, so that if you log on and you have privilege level 2, you have a predefined set of commands that you can use on the device itself. Privilege level 15, if we do that, it's going to automatically take us into the privilege exec mode. Privilege level 1 is going to be the default. The profile information, what can a user do, and where do you get where can a user do? Different methods to do that. The configuration steps, AAA authorization, network TACACS Plus. We'll do AAA, and when we do AAA, we'll configure a radius server to do that. A couple of other things, but the AAA authorization, AAA authentication in order to configure these things. Authorization here, and what do we want to authorize? Exactly the exec modes. TACACS Plus, or we can do the other things. Authorization, exec accounting tracks what the users did while they were on the network. Actually, what it does is kind of tracks user activity. The accounting here is not going to be nearly as extensive as you might get from an Active Directory if you have used Active Directory accounting. Accounting records to manage the information related to the user activity. Store the attribute value pairs on the server, and we can only have accounting if we don't have a local user. We have an authentication server, either a TACACS or a radius server is the only place that we're going to have accounting. Enable TACACS accounting. Same basic process. AAA accounting network start stop. The start stop is start a management session, stop a management session. So it doesn't really give you the extensive logging for who, what, when, where, how, who did what. Because in Active Directory you can configure who did what, when did they do it, what did they do, modified a policy, and here's what they actually changed. We can't get to quite that level with these exact start stop TACACS, and then the TACACS server is configured to track privilege exec access. Two kinds of instructions to the device: a start record when the user enters privilege exec mode, and a stop record when they get out of privilege exec mode. Again, not the kind of logging, I guess, that we would visualize that we would really want to have. And so this is just the configuring, the step-by-step to configure TACACS. User TACACS username, password used in NetSim, and then TACACS key phrase used in NetSim. The different things that could be used in there, and then there is a couple of labs that are available. This one you can't get to. Radius operation, Radius remote access dial-in user service. Radius, another one of those that's been around for years and years and years. It's open source. TACACS Cisco proprietary. Radius open source, which maybe says, hey, I might want to use that one instead. It also can be incorporated if you're using an Active Directory server to get the usernames and passwords from the Active Directory database. So it can be taught to communicate with Active Directory so that when you type in your username and password, it's going to use the Active Directory one, which means that that's one username and password that we don't want additional username and password we don't have to configure. Authentication is performed through interactive dialogue for this. It uses UDP ports 1812, 1813, 1645, and they forgot 1646. Packet tracer uses the old ports, 1645 and 1646. The ports that most of them are going to use now are 1812 and 1813. One of them, the 1812 for authentication, 1813 it would be used for, it's an open standard protocol. Once the server finishes authentication, sends a response to the device. Very similar to TACACS, accept or reject. And those are the two that we had, and those are the two things that are going to be similar. We may get a challenge that the user is challenged to enter more information. We had that with TACACS. The other thing is a challenge password. The user is prompted to enter a new password. If it's successful and authorization settings are enabled on the device, the server validates the user's permission, sends an accept or reject, just like we did with TACACS. So the Radius host components, we have the host name or IP address of the host which acts authentication, destination port, the accounting destination port, the timeout period that we would have with these things, and then the retransmission value. The key string down here is a shared secret. The shared secret is configured on the Radius server and is configured on the device. It's a mutual authentication. The commands in order here at the bottom of the Radius server, host, and then the host name or the IP address. Host name, we would have to have either a host file, a host name file, a hosts file, or be able to resolve it in DNS. The authentication port, authorization port numbers here, the accounting port, the port number, not authentication port, and then the timeout in seconds, retries it if we have unsuccessful. The key string here is going to be the shared secret, so that the Radius server and the device that it's being configured on know that they should be talking to each other. Can use different ports. We can specify them if we want. Each port dedicated to provide authentication, authorization, and accounting. A client uses a unique identifier, combination of the hostname or IP address and the UDP port to access the required AAA service from the Radius server. So we're going to Radius authorization, and when we look at these things, what we're doing, the differences between Radius and TACACS are minimal. Just that the protocols themselves, the differences aren't minimal. The TACACS Cisco proprietary TCP port 49, Radius open source UDP. And when we get into these things a little bit, Radius is a single authentication and authorization. We'll get there. There are some differences in them, but the processes are basically the same. Log in, username and password, we get a yes or a no when we do these things. User authorized to access the Radius authorization process, the same steps that we had with the TACACS authorization. Authorization, network Radius. What can we do? Authorization, exec. And these are the classification of the commands that we can do. The exec, the privilege exec commands. The network commands, can we do IP addresses and the network sorts of configurations on the device. Restrict access by entering the AAA authorization Radius global configuration command. Accounting tracks the services and resources accessed, just like we did with TACACS. Radius uses the accounting records, manage information related to the activity, same way as TACACS. Processes the meat, the quality is probably not the word that I want, but the extent, I guess, maybe that they do are going to be different for each one. Uses the accounting records the same way as TACACS. The steps to configure the Radius are same as before. Network start stop radius. Exec start stop on the radius server. Counting exec start stop radius. Counting network. So what we're going to do, what are we going to measure? And this one's the same with the privilege exec mode. And when a session starts, it gets recorded. When it stops, it gets recorded. Again, not the extensive configuration that we might expect. The load balancing, if there's lots going on, then we can put multiple, it's called radius group. And the reason it's called radius group is because we can have more than one server in the group if we want to have that, if we need that. That's a maybe or maybe not. I think that you're going to have a lot of users. The Windows has or had or probably still does a little calculation of how many Active Directory servers you needed in order to authenticate however many users. And we were up to 600, 700, 800, and we needed less than one server from a load perspective. You need two servers and for a backup, from a backup perspective, in case one goes down, so that the other one can keep going. So if you have a really big network with an awful lot of people authenticating to the radius server, then you may need to do load balancing. Load balancing, multiple radius servers, whichever one's got the lowest CPU load, whichever one's kind of sitting there waiting for some work, the system will give them work. Reduces the CPU load, improves response time in the group itself, works by assigning batches of AAA transactions to the individual servers, and each server in the group uses queues to store the transactions assigned to it. Queues. The load balancing process, a new service request received for the first time is considered a new transaction and is placed in a new batch. The batch is then the subsequent transactions, more transactions added to the batch, till the batch sizes limit. The batch sizes are specified during the configuration. Then the server queue that has the least number of transactions in it is going to be selected, and that's where that batch is going to go, so that it can go through the authentication, authorization, and accounting process. Summary here, a little bit of a summary for these things. The radius, TACACS, which does what to which other one. The radius combines authentication and authorization. Where in TACACS, it is separate processes. Radius encrypts the password. TACACS encrypts the username and password. Radius requires that each network device contain the authorization configuration. Central management for the authorization configuration on TACACS. No command logging on Radius. Full command logging on TACACS. Minimal vendor support, it says, and it's supported on most major vendors for TACACS. Radius is UDP connectionless protocol. UDP ports 1645, 1646, 1812, 1813. 1645 and 1646 were we'll call the old ports, maybe the original ports that we had for these things. And the newer systems, you're going to see 1812 and 1813. Except in packet tracer will be 16. It's designed for the AAA subscriber. Back to TACACS. It uses TCP. It's connection oriented. TCP port 49, and it's designed more for